Welcome to the DIY Honda Garage channel. The DTC P0137 refers to a problem with the secondary heated oxygen sensor, specifically indicating a low voltage condition in the circuit associated with this sensor. The secondary heated oxygen sensor 2, HO2S2, plays a crucial role in monitoring exhaust gases and ensuring the engine runs efficiently by helping to control fuel injection and emissions. Typically located in the exhaust system after the catalytic converter, this sensor helps assess the efficiency of the catalytic converter. The diagnostic trouble code, DTC, indicates that the voltage reading from the sensor is below expected levels, which could either affect engine performance or emissions compliance. Ensuring this sensor works properly is vital for maintaining optimal engine operation and adhering to emission standards. In the next slides, we will dive into the steps necessary to troubleshoot this circuit issue effectively. The secondary heated oxygen sensor 2, HO2S2, monitors the vehicle's exhaust emissions, specifically focusing on the oxygen levels relative to the exhaust's composition. This sensor is strategically located in the exhaust system, post-catalytic converter, to evaluate the efficacy of the converter itself. It communicates directly with the powertrain control module, PCM, sending voltage signals that the PCM uses to adjust the air-fuel mixture, thereby optimizing fuel efficiency and minimizing emissions. A low-voltage signal, such as indicated by DTC P0137, suggests that the sensor may be malfunctioning or that there could be a wiring issue in the circuit that hinders proper electrical flow. Identifying these components' exact roles and positions allows for targeted diagnostics, ensuring swift resolution of the issue. Several factors can lead to the activation of DTC P0137. A primary possibility is a malfunctioning secondary heated oxygen sensor itself, which could be sending incorrect voltage readings to the PCM. Additionally, wiring issues, including shorts or damaged insulation, can also disrupt the signal between the sensor and the PCM. Poor connections at either the secondary HO2S or the PCM terminals could further exacerbate the situation, potentially leading to intermittent faults. It is essential to closely examine all areas where electrical connectivity occurs, particularly paying attention to corrosion or looseness in connections. Verifying these possible causes sets the foundation for accurate troubleshooting and repair. When DTC P0137 is triggered, several symptoms may manifest. The most immediate is the illumination of the check engine light, CEL, on the dashboard, alerting the driver that the vehicle requires service. Additionally, drivers may notice a reduction in fuel efficiency as the engine struggles to maintain the correct air-fuel mixture due to incorrect feedback from the oxygen sensor. This can lead to higher emissions and potential failure during emissions testing, thereby compounding the problem. Awareness of these symptoms is crucial for early detection and addressing the underlying issue before it escalates into more severe problems affecting overall vehicle performance. The first step in troubleshooting DTC P0137 involves confirming the problem. Start by turning the vehicle to the on mode while ensuring all electrical systems are active. Following this, use the HDS, Honda Diagnostic System, to clear the DTC from the system. Once cleared, switch the vehicle to off lock mode and then restart the engine. Allow the engine to idle without load. This means placing an automatic transmission in park or neutral, or a manual transmission in neutral, until the radiator fan activates. After this process, monitor the OBD status for DTC P0137 using the HDS. If the HDS indicates a failed status, this confirms the problem persists and you can proceed to step 2. If passed or intermittently failing, It may indicate that the system is currently functional, but it's wise to inspect for any loose connections or damaged terminals at the secondary HO2S and PCM. For the second troubleshooting step, commence by ensuring the vehicle is turned off, lock, for safety. Disconnect the 4-pin connector associated with the secondary HO2S. Switch the vehicle back to on mode, and then utilize the HDS to evaluate specific parameter values necessary for diagnosis. Specifically, check the voltage reading from the HO2S S2. This should be less than 0.17 volts under current conditions. If these conditions are met, you can confidently assert that the secondary HO2S is failing and move on to step 3. Conversely, if the readings indicate otherwise, replace the secondary HO2S. This diagnostic step is critical, as replacing the sensor could resolve the voltage issue. Step 3 involves identifying potential shorts in the HO2S line by checking for continuity. With the vehicle still in the off-lock mode, you need to test continuity between 2 designated test points. These points include the male terminals of the secondary HO2S 4P connector, specifically terminal number 1, and the body ground. The absence of continuity suggests a break or fault in the wire between the HO2S and the PCM. If continuity is present, proceed to step 4, where more targeted checks can be performed. This step is essential for diagnosing issues that involve wiring faults or shorts that influence the sensor's operation. During troubleshooting step 4, the focus shifts to identifying shorts specifically within the SO2 line. Begin by jumping the SCS, short circuit switch line, with the HDS. After waiting for more than 1 minute, disconnect the PCM connector A 50P. Check for continuity between 2 test points, the HO2S connector, terminal number 1, and the body ground. Its continuity exists. It confirms that a short in the SO2 wire is present between the PCM and the secondary HO2S, warranting a repair of the affected wiring. If there is no continuity, this indicates that the wire is intact. You should then seek authorized service information regarding the DTCs or consider substituting with a known good PCM to further isolate the problem. The final troubleshooting step requires checking for a short in the SO2SG/SO2SG line. Similar to the previous step, initiate by jumping the SCS line using the HDS and waiting beyond 1 minute. Disconnect the PCM connector A 50P while keeping the secondary HO2S sensor 2 4P connector disconnected as well. Check continuity between the second test point, terminal number 2 of the HO2S connector, and the body ground. If continuity is present, it indicates a short in the SO2SG/SO2SG wire exists between the PCM and the secondary HO2S, which needs to be repaired. If no continuity is found, it means that the SO2SG/SO2SG wiring is intact. From here, you should refer to service documentation linked to the DTC or consider using a known good PCM to aid in diagnostics. Upon completing all repairs tied to DTC P0137, it's crucial to verify that all connections are secure and free from corrosion. Ensuring proper connectivity at both the primary and secondary HO2S as well as the PCM underlines the integrity of your repair work. Following this inspection, prepare the vehicle for a road test to observe if the engine operates smoothly without triggering the check engine light again. Lastly, use the HDS to conduct a final diagnostic scan, confirming that the DTC P0137 does not reappear and that all systems have cleared properly. This step ensures that the repairs executed have resolved the underlying issue, ideally restoring the vehicle to proper operational status. Preventive maintenance is essential to avoid future occurrences of DTC P0137. Regular checks of the secondary heated oxygen sensor, along with its connections and wiring, can prevent unexpected failures. Monthly visual inspections of these components help in identifying wear, fraying, or corrosion before they become critical issues. Ensuring that all electrical connections are solid and free from environmental contaminants is also vital. Periodically diagnosing the vehicle's onboard systems using the HO2S will help catch any irregularities early. Implementing these practices not only extends the lifespan of the HO2S, but also contributes to the overall efficiency and cleanliness of the vehicle's exhaust emissions. In conclusion, the proper functioning of the secondary heated oxygen sensor is critical for maintaining fuel economy and minimizing emissions in the Honda Accord. Diagnosing and correcting the issues surrounding DTC P0137 requires a systematic approach to troubleshooting, where each step is carefully executed to isolate the fault. Being aware of common symptoms and possible causes can streamline the diagnostic process significantly. Furthermore, implementing a regime of regular maintenance can proactively address problems before they escalate. By committing to these practices, the longevity and reliability of the vehicle's emission systems are ensured, ultimately contributing to both environmental compliance and driver satisfaction. Please like and subscribe to the channel. See you next time.